What's up, everybody? This is Ed from my Bringback, and you are joining us right in the middle of a series of videos in the language R, where we're exploring the basic plot commands. And today what we're going to do is spend a little bit of time on scratching the surface of color in R plots. There's a lot of ways to accomplish a lot of pretty cool things, but we're going to start with the very basic building blocks of color. So let's take a look. Okay, so we're going to start like we have in the last couple of videos with just some nonsense data. It doesn't mean anything, but we have x here. All the values between 1 and 100. Y is the logarithm of x. And if we take a look at what that plot looks like, you can see here nothing too shocking. We've got hollow black circles along a white plane. We can spice it up and change it by simply setting a color parameter, and we do it like this. Within the plot command, we say color equals, and you're always going to pass it strings. Now, R has a big list of colors, and we'll do some exploration of that in future videos, but let's just start with something basic here. Let's make it red. And if we swap back over to our null device, you'll see, not too complicated. There you have it. X and Y, and all of the points are red. Now that's not too useful or too exciting. We don't have a lot of reason to change that red outside of aesthetic purposes we may have, but let's add some more information to this plot. So we'll make a third variable here to illustrate the point. We'll say z is equal to x divided by 25. And if I want to add information to a plot that's already active, put something in the null device for that remapping, I'm going to do points. Points is a command that will add information to our current plot. So we'll do points z here. And if we pan over, we can see you have the line here, the simple linear result of x divided by 25. And now we understand why you might want to use color. We're going to want to differentiate between x and, y and z here, or between the two different sets here, because especially down in this lower left corner, it's tough to tell which thing we're looking at. So what we would do is say when we add point z, we can set our color parameter, and we'll just make these green. And like I said, you got many colors to choose from, but we'll just use easily recognizable ones. And we go back over to our plot. Now we can easily tell that lower one is black, and it belongs to just the x and y values, and the z and x values are in green there. So that is a very basic look at color and how you would employ it to differentiate things. Now that's one way you can do it, and it's very nice because we have three vectors we're representing, but we don't have to use a three-dimensional plot. This is something we could easily print and show to people and have it be quite communicative. So this is why color is important and how we map things. So let's take one further look at very basic use of color, and that's to color something by a property it has. And to do that, we are going to load up one of R's built-in data sets. Now this is something you'll see probably if you explore any of the other good tutorial information or just basic instructional things that are out there, that R has built-in data sets of a variety of sorts. So we're going to use one of those data sets called iris, and it's about flowers. So we use the command data iris to do that. If you want to look at it, you certainly can. Too big for the screen, but if you look at just the head of it, which we've taught you to do repeatedly, you can see we have 5 different qualities of iris flowers. And we're going to use color to differentiate between them, and I'll show you how. So I'm going to plot some vectors out of this data frame, some columns, and we'll do this quite simply by issuing the command plot iris, and we'll subset iris to, we'll say, petal length. And I don't know a darn thing about irises, but petal length makes sense to me, so it's petal width. So those are easy enough to understand. Let's see if looks like anything rather when we plot it. Iris petal length and iris petal width. And if we issue this command, we'll see we get, well, looks like in general, as the petal length increases, so does the petal width. That's informative. But these are irises of different species, and maybe the species will have different petal lengths and petal widths in general than each other. Maybe they'll be differentiated that way. And so we can issue a command like this. We'll say color, and instead of setting it equal to a string that represents a color value, what we're going to do is just set it equal to some factor property of this data set. So it can automatically determine how to color it by a factor, and the factor we're going to use is species, like I said. So iris and the species quality. And when we issue this command and plot it, look back over at a device, you can see that each species has its own color, And in general, this green species up on the top right has longer, wider petals than the other two species, and the black colored species down there at the bottom has shorter, thinner petals than the other two. So that is a very basic examination of how you can use color to differentiate points on plots. And we're going to spend more time in the future on color because there are a lot of very neat things you can do with gradients. There's a lot of very interesting ways you can get a lot of information into a simple two-dimensional space. But that's a taste. And my name is Ed, working for my Bring Back. Please keep coming back, keep pushing play, keep checking these videos out, and we'll keep aiming to please.